In this video, we're going to work through homework number 37, number 43. So we have a picture here where you can see our boat is at point P, which is 2 miles out from the shore, from the river bank. And we're trying to get to a point Q, which is 3 miles downriver and then a mile back from the river bank. So we're going to consider, so we've kind of labeled this a little bit. So we have P, Q, R is this point that's on the shore, right where Q is, 3 miles down from where P is. So we're going to look at some different options. One option is going to be option number one is to just row as little as possible. So row straight to the riverbank, following that blue path. And then once we're on shore, then walk to point Q. So that would be and maybe I should write that a little bit more like we would, so our Q is really going to be more down here. So, I don't know, well, let me erase that now, or will it? There we go. So really we're going to make our path more this way because Q is going to be a mile inland from the riverbank. So that's one option. And to do that, we're going to look at 2 distance equals rate times time. So the distance 1 equals rate 1 times time 1 is the boat ride. And so that's going to be just the distance 2, the 2 miles we're going to row straight to shore, is equal to the rate, which is the speed of the boat, 3 miles per hour, times a T1 that we don't know. So if we solve that for T sub 1, we'll just divide the 3 over and say that part of the trip is going to be 2/3 of an hour, just the rowing the boat straight to shore. Then we're going to have to walk the diagonal from the right at the water line, right at the riverbank there, to our point that is 3 miles downriver and 1 mile in from the edge of the water. And so to find that diagonal length there, that's the hypotenuse in a right triangle. So d sub 2 squared is 3 squared plus 1 squared, and that makes d sub 2 equal to the square root of 10. So that makes our second d2 distance equals rate times time. d2 equals r2 times t2. We know the distance is going to be that square root of 10. The rate at which we walk is 4 miles per hour times the time that we don't know, t sub 2. So solving for the t sub 2 gives us square root of 10 over 4. So then the total time is going to be the time it took to row to shore plus the time it took us to walk diagonally to point Q. And if we throw that on a calculator, we can see that's 2.248 hours. So that's one option. The second option is if we try to kind of minimize the amount we spend walking. So in that case, we will try to row our boat all the way to point R. That's the point closest to our final destination Q. And then once we get out of the water, we'll walk the 1 mile to point Q, our destination. So the first one, our first distance equals rate times time, d1 equals r1 times t1, is we got to find out what the distance is rowing diagonally across the water there. So we're 2 miles from shore, and we are 3 miles downriver. So our d1 squared is 4 plus 9, 2 squared plus 3 squared. So that's going to make d1 the square root of 13. Then we will get d2 equals r2. So solving for time 1, we'll get that square root of 13 equals the rate at which we row 3 times the time 1. And so the time 1 is going to be square root of 13 over 3. The second d2 equals r2. t2 is just that straight walk, that 1 mile walk. So we have 1 for the distance, and we have 4 for the rate. And so that's going to make our t2 be just 1/4. So the total time for that trip is going to be the square root of 13 over 3 plus 1/4, which from our calculator turns out to be 2.141 hours. So now we're going to see if we can beat that time. So far it looks like we're trying to find a way to get there in under 2.141 hours. So now is where it gets really interesting. So we're aiming for this point where we're X miles down river from where we are in the boat. And so that first distance d1 is going to be the Pythagorean Theorem, where 2 is one side and x is the other. And so we're going to get that d1 is going to be the square root of 4 plus x squared. So in our formula, d equals r times t, we have our distance is square root of 4 plus x squared. The rate at which we're rowing that boat is 3. So solving for t1, we're going to get that part of the trip, the rowing the boat part of the trip, is the square root of 4 plus x squared all over 3. Now the second part, once we're on shore here, then we're going to walk in a straight line as quick as we can to our point Q, our final destination. So since we're X miles down river from where we were originally in the boat, and the whole distance is 3, that means we're 3 minus X along the water line, and we're 1 inland. So that gives us a Pythagorean Theorem question again. So d2 squared is going to be the 3 minus x squared plus 1 squared. Squaring out the 3 minus x is 9 minus 6x plus x squared, plus that other 1 gets us 2x squared minus 6x plus 10. So d2 is the square root of x squared minus 6x plus 10. So in our formula, distance equals rate times time, the rate at which we're walking is 4, so that's going to make the t2, the time it takes for the walking part of our trip, the square root of x squared minus 6x plus 10 all over 4. So that means our total time is going to be the distance we spent rowing plus the distance we spent walking. And we're going to try to find what that minimum time is. So to find a minimum, we are going to take the derivative, set it equal to 0, and try to solve that and find out what that time is and see if it is actually less than our 2.141 hours. So to take this derivative, so we're taking dt dx, the derivative of our total time with respect to x. So I'm going to think of that over 3 as just being a 1/3 constant times that radical. And so thinking of that as 4 plus x squared to the 1/2, this is going to be a chain rule derivative. So it's 1/2 times 4 plus x squared to the negative 1/2 times the derivative of the inside function, and the derivative of that x squared is going to be 2x. Then the second part of that, I'm going to think of that divide by 4 as just the 1/4, multiplying that. Another chain rule derivative is going to be 1/2 times x squared minus 6x plus 10 to the negative 1/2 times the derivative of x squared minus 6x plus 10, which is going to be a 2x minus 6. So let's see if we can clean this up a little bit. And we're going to set this equal to 0 and try to solve that. So I guess we can cancel the 2 and the 1/2 here, and that will take us to, I'm going to write that as this x on top, and I'm going to put the 3 and the square root of 4 plus x squared all in the denominator. Plus, and let's see, if we notice here that we can factor a 2 out of that 2x minus 6 and cancel that 2 with the 1/2, and then I'm going to write the x minus 3 in the numerator and leave the 4 from the 1/4, and that negative 1/2 is going to go into the denominator as a square root. Now, what we want here is to find where this is equal to 0. Well, this is a crazy tough problem. Remember, this is our t prime function. But let's just use our calculator here. So we can enter all of this stuff into our calculator as y sub 1. And we can just try to find the 0. Where is that equal to 0? And so we can set our x min and x max. Since x can only go from 0 to 3, then you can choose your x min and x max to be 0, 3, and your y min and y max, we're just trying to see where this crosses the x-axis. So we can just set it for negative 1 and 1, graph that, and try to find where that is equal to 0, where it crosses the x-axis. And I believe when you do that, we're going to get 1.563. That's rounded to 3 decimal places. Now remember, this is the x value, and we are trying to, I think that's what we were trying to find. I'm trying to remember the original. Yeah, it said find x. So if you want to check the time, you can store that value. So if you quit the screen, go second mode, and then before you do anything else, store that into x and hit enter. Then you can, the calculator will keep all the decimal places that you found from finding that 0, and then plug that into our time value right here, and we'll see if we can get a value of time that is going to be less than that 2.141 hours. So when you plug that in, that t of our 1.563, then what I got was 1.284 hours. So you can see that that is shorter than the 2.141 hours that we got with the better of our two options, rowing and walking the minimum distance. All right, hope that helps.